Please welcome to the stage Corporate Vice President, Developer, Platform, and Tools, Nat Friedman.
Thank you. Thank you. It's great to be here. As Scott said this morning, Microsoft is focused on developer productivity. But why are we so passionate about this? It's because software is driving more and more of the things that we do every day. And because everything is getting an API. Now, as developers, for us, that means we can call an API to do almost anything. We can call an API to transfer money or to ship a package. We can call an API to get our heart rate off of a wearable device or to ask our car to back out of the garage. We can use machine learning to call an API to translate from one language into another or to interpret an X-ray or to do 1,000 other things. And as developers, this is amazing for us. We love it because it's almost like we get a new superpower each time a new API like this is released. But our companies love it too, because the code that you write is helping your companies to engage better with your customers. It's helping you to build breakthrough, innovative products that compete better in the market or that disrupt entire industries. And it's helping your employees be more efficient and productive and get more done and save money. So all of these benefits are driving demand for the work that developers do. And in fact, there's already 5 times more demand for mobile developers than today's teams can supply. So developer productivity is important for that reason. But it's also because the tech landscape is changing. And so, for example, there are more devices and platforms that your apps have to run on now than ever before. And in fact, last year, the average employee to do their job used 3 separate devices each day. And the diversity is only increasing. There's also new emerging technologies like voice interfaces and conversational interfaces, wearable devices, and mixed reality, and they're all awesome. They're so cool. We want to support these things, but we're busy too, and to learn each of these new things and add support to our apps or build new apps, it takes time and energy. It takes effort. Additionally, by being on their digital devices all day long, users are throwing off more data than ever before. And that creates a challenge for us as developers to collect that data, to store it, to manage it, and then to analyze it and understand what it means and derive some insights from it. So these are the reasons why developer productivity is so important. We have to do more with the same amount of resources. Now, speaking personally for me, I've been managing software engineering teams for years. And in that time, when my teams are in a crunch, I've developed a great technique for getting more work out of them. I just tell them, type faster. Now, I know you may be skeptical, but think about it. If you can go from 100 words per minute to 1,000 words per minute, the problem's solved. We're done. So, unfortunately, I've done some research recently into typing speeds, and it turns out that despite major technological advancements in typing technology, like ergonomic Dvorak keyboards. Any Dvorak users here? Got a few. There's always one. And high-octane energy drinks like Monster and Rockstar, typing speeds actually plateaued in the late 90s with the introduction of Mavis Beacon 3.6. So, if we're going to make developers more productive, we're going to have to do it some other way. It's not going to be because they type faster. So the question is, what makes a developer more productive? Well, really, it's about eliminating steps. How can we help you eliminate the repetitive tasks, the inessential tasks, so that you can focus on what is different about the app you're building, what's unique, and what the actual problem is that you're trying to solve, not the infrastructure, not all the basic stuff. After all, this is sort of why we created computers and software in the first place, is to do the boring, repetitive work for us so that we can focus on what's interesting. So we divide this into 3 different areas. First, we give you powerful building blocks that make it easy for you to do the basic things like store your data, scale up, manage and monitor everything that you're doing, but also make it easy for you to add advanced functionality to your apps like artificial intelligence. Second, as developers, we love to write new code. That's the most fun thing, right? But the truth of our jobs is that we spend 80% of our time in existing code or old code because we have to debug it, we have to fix it or enhance it. Sometimes we're just trying to figure out what it does, and it's hard, it's time-consuming. So if you have powerful tools for diagnostics and debugging, these can actually make you much more productive. There's a lot of lever there. And then finally, apps today operate at a scale that is so high that they require tremendous infrastructure. And it's just not realistic for the average team to build a global scale, incredibly performant, reliable storage networks and compute networks that people need today for their apps. And so the more of that you can offload onto Azure, onto the cloud, so that you don't have to do it, the more time you've freed up for yourself to focus on your app in particular. So these three pillars of developer productivity will be the themes of the demos that you're going to see today. And we have 4 demos for you. First, we're going to look at how to build amazing app experiences across devices. We'll look at Azure and how to take advantage of the hybrid and scalable cloud to power your apps. We'll show you how to drive data-driven intelligence into your apps so that you can make intelligent decisions. And finally, we'll show you practices and powerful tools that you can use to adopt continuous innovation and great development practices. So let's start with amazing app experiences. Users today, many of them have grown up on incredible consumer apps on the web or on mobile devices. And they really have low tolerance for bad apps. That's changed. The bar has risen. If your app hangs, if it's slow, if it crashes, if it just doesn't have a well-designed user interface, people are much less likely to use it than they used to be. There's a lot more choice. They also want apps to take advantage of the latest features and functionality on each device, but they also want the freedom to be able to run their apps on any device. So with Visual Studio and Xamarin, you can build apps that run natively on iOS, Android, and Windows. You can share up to 90% of your code, and you can do it all using C# and .NET. With Visual Studio Mobile Center, you get a complete end-to-end mobile DevOps solution that lets you build, test, deploy, monitor, and improve your apps over time, all built on top of Visual Studio Team Services, so you get great, powerful functionality, and you can collaborate with the rest of your team. So to dive into this, please welcome Xamarin and Visual Studio Program Manager and my friend, James Montemagno. James, there he is.
Awesome. Thank you so much, Nat. All right. Number 2 of the day. Let's do this. I'm super excited to be here with everyone to really show you exactly what Nat was saying, the power of Visual Studio, C# and Xamarin, and of course, Azure, the building blocks and great foundation. Now, several of us are going to show you awesome end-to-end cloud-connected experiences across all sorts of different environments. I'm going to show mobile, some DevOps, a whole bunch of awesome stuff. And we're going to do it all around a company, airline, startup that we created and envisioned called Contoso Air. We're real original with our titles of names. Now, what's cool about Contoso Air as a startup is they want to be real agile. They want to be able to go to every single platform, whether it's web, mobile, or anything else that you're going to see in really cool demos up here today. So from personal experience, I know that that's really daunting. Over the last 6 years, I've developed 70 some odd applications across all these platforms. So I know that's a challenge. And like I said, we have the building blocks to do that. So I'm going to start actually on the Contoso website right here, on the Contoso Air website. And like every kind of business out there, you have a beautiful website. Down here, I'm logged in with my Microsoft account so I can actually see some recommendations. I'm actually going to Paris next week, which is cool. But I sure would love to go to Barcelona. Here, and we're using some graph and some intelligence to come in to actually pull in really rich things like streaming services, find out about Barcelona, see some flight deals that are coming up. Well, of course, I'm going to fly from Seattle, where I live, so let's go ahead and see if I can book a flight, get some upcoming deals for October, and then, of course, go ahead and pick my seat. And what's nice is it knows, based on my recommendations, everything that I need with just a few button clicks. And I'm basically done. So that's the web experience, and that, of course, is all developed inside of Visual Studio. So here, I have my Visual Studio solution. So as I go in, I have a Xamarin application for my mobile apps, here for Android, iOS, and Windows 10. And I also have my ASP.NET Core website and powerful web APIs that can drive my mobile applications. So let me show you the mobile applications before I even jump into the code. So here I'm going to go ahead and launch the Windows 10 and Android version of the Contoso Air mobile application. And you're going to see a lot more of this, so I'll kind of give a high-level overview. But here I have a lot of similar features, but in the native Windows 10 and Android look and feel because they're native applications. I can find a flight, or if I want to come and see some things that I've booked, I just go into the flyout navigation here. Boom, there's my trips. And I'm getting the look and feel and the correct refresh on each of the different platforms. When I go to check in, proper navigation, look and feel of native because Xamarin applications are native. And then I'm ready to go. I have everything I need for my trip upcoming. So these are two of the three applications because they want to go everywhere. So of course, I want to deploy to iOS. So inside of Visual Studio, you can see in the debug menu, it finds all of my actual iOS simulators or physical devices that I'm connected to. So here I'm just going to hit debug. And this is going to do a full compilation on my iOS device over here in Visual Studio and launch our remote iOS simulator for Windows. So when you need to do a full compilation, access every single bit of the hardware capabilities, you have access to all of them in C#. And then here, I can use the iOS simulator, and I'm getting the iOS look and feel with tabs on the bottom. So I can go in, check in, look at my contact, and everything like that with beautiful animations, giving unique experiences to all three platforms that users are going to expect. Because there's a reason that someone bought a Windows device, Android, or iOS. They like the hardware, but they love the software. So we give you the building blocks to do that. Now let's look at the code. Now inside of Visual Studio, what I love about this project is that 95% of the code is shared. Everything is in this .NET Standard library with advanced animations, behaviors, value converters, things that .NET developers know and love already, whether they're building desktop, ASP.NET applications, anything like that. We have powerful data services to actually do authentication, deals, trips, and of course down here we have all of our views. Everything here is built with a cross-platform XAML markup for all of our user interface. And in the past, I'd have to go build this application in three times in 3 different languages. Then with Xamarin, I could build an application all sharing a bulk of my code, but build out separate UIs. Now I get to pick. Do I want to build out those native user interfaces 3 times or use a cross-platform native user interface here with the XAML? So what's great, as Nat was talking about, is those building blocks, those core fundamentals, and cross-platform APIs that developers are going to call. So here, for instance, in my authentication service, if I want to go off and log in with the Microsoft authentication library, a single call to call into my authentication client and acquire a token all asynchronously. I'm using standard and awesome C# features like here, like obviously string interpolation, but async await and nullables and all that great stuff. When I want to go in and see what else I'm sharing and I want to pull back that data for the first view, I, of course, have all my data models coming in here. And I'm using the power of Visual Studio for all of my integrations in Git. The deal service, what do? I'm making RESTful service calls out to my web backend. And then, of course, I have my user interface. So I have my trip views, where I have observable collections, things that my user interface cares about when I'm doing a pull to refresh and reloading that deal data. And then, of course, the views. I talked about the cross-platform XAML. We give you all the XAML features that you know and love, such as styles and resources and data bindings. All in here is a list view with pull to refresh. And we do things that are really awesome because we know that your designer may want you to tweak it a little bit per platform, so you can go and do on-platform calls. Now, while a full demo end-to-end is great that we have here, I really like to show what it takes to get started and how we've simplified that. So I'm going to switch over to another Visual Studio where I'm in a different branch of this project. And I did file new here to kind of walk you through our beautiful templates for iOS, for Android, iOS, and iPhone, iPad, but even Apple Watch applications, and even tvOS applications. And then we have cross-platform templates to build out the UI and your ASP.NET Core backends. So one click, you get all of your applications. Now, if you're at the keynote at all, you may have seen me talk about the Xamarin Live Player and how it was working to enable developers to get started faster. Well, while we have great emulators and simulators, sometimes I just want to work on the user interface or a little bit of my logic, and I don't want to have to go through that over and over again, compile, debug over and over. I just want it on my device. So I'm going to show you this again right here. I'm going to open up my iPhone. So let's get my iPhone up there. There it is. Cool. And basically what we've done is we have the brand new Xamarin Live capabilities in Visual Studio and the Xamarin Live Player application on my iOS or Android device. So I'll go in. I'm going to go ahead and pair this here. So all it takes over your local Wi-Fi, nothing more than your PC and an iOS or Android device. And with that screen glare, boom. Now, essentially over Wi-Fi, I've connected to the Live Player, and I'm ready to deploy. So here, it takes all of my source code, ships it all over to the device, and then on device inside the Live Player, it's going to interpret the actual source code. So it's going to ship it all over and then compile on the device, and boom. We have a login screen. I can log in with Microsoft and even hit breakpoints right inside of Visual Studio, all over Wi-Fi with just my iOS or Android device. And it's my full application, so you can see I have a few UI changes and modifications I need to do in here, especially that login screen. So let's stop debugging and come back to that login view. So here I'm going to put it in my favorite mode, which is Live Run Current View. So I tap on that, and that single screen, the screen that I'm working on right now, is automatically redeployed. So it has a gray background, but I'm going to go ahead and modify, and my designer gave me some images here to put in. So we'll set the source to background.png and close it out. What it does is wait for me to finish, and then essentially ships those changes over to the device. Let's give it a second, and boom, there it is. And it automatically is not only just showing the user interface, but it's also doing all of my data bindings, all the commands, and running my app live. So from Visual Studio, you can start building beautiful cross-platform applications with just an iOS or Android device. And then as you go further, use all of our great tools that you have for mobile development. Now, some of you may prefer Mac machines to do all of your development and web development. So let's head over to my Mac, boom. Let's get rid of the iPhone. Nope, go back to the Mac, there we go. Perfect, perfect. Now that's where Visual Studio for Mac comes in. It's the ultimate .NET IDE for the Mac. So here is Visual Studio for Mac. It looks and feels like a native Mac app because it is. So I can come in and, as long as I have a mouse, there we go, I can hit New Project. Inside of here, I have all the templates, iOS, Android, even Mac desktop applications, alongside my ASP.NET Core workloads and Azure workloads. And what's great here is that no matter where your source code is in version control, you can open the same projects and solutions. So this is the same exact project and solution that I just had open in Visual Studio 2017. Everything synchronizes and opens seamlessly. And all the tools that I showed you, the simulators, Xamarin Live, are all in Visual Studio for Mac, making your team super productive no matter where they're working. Now, I've just been developing the application, but at the same time, the things that I don't want to have to worry about on a day-to-day basis is building, deploying, and getting it into my users' hands, but also getting valuable insight. And that's where a full mobile DevOps production pipeline comes in with Visual Studio Mobile Center. So I'm going to hop over here into Mobile Center. And here's Mobile Center, and I've connected all of my applications. So I have Android, iOS, and Windows 10. And this is essentially, Mobile Center is the mission control for my mobile applications, giving me all the services that I could possibly need. So here what I'm going to do is tap on iOS, and we have a cross-platform SDK for crashes and analytics that I'll show you, but I want to start with the build, which is the first thing I want to do, set up continuous integration, and I'm going to do it in just a few seconds. Here, Mobile Center is connected to Visual Studio Team Services, and it pulls in all of my branches of my source code. I can see who's been working and who's been has builds or successes or failures right here. And we see there's some triggers on push or manual. I could also connect this to GitHub or Bitbucket if I needed to. But let's set up a new one for this development branch that Brady's been working on. I simply say connect, and now what Visual Studio or Mobile Center is doing is it's scanning my repo. And what it's going to do is analyze and say, hey, these are all of your solutions that we found in VSTS. So let's go ahead and build that Xamarin iOS project. Then it will tell me, oh, let me go ahead and do debug. It scans that project. And what versions of Xcode do you want? Do you want it on a device or simulator? How do you want to build this? Do you want to incrementally build this with an increase of version numbers with every push and sign the builds or even automatically deploy them to my users? Then I hit save, build, and what this is doing is actually scaffolding out a Visual Studio Team Services project all under the hood for me. Mobile Center is powered by Visual Studio Team Services, so what that means is that Mobile Center has now leveraged all the power of VSTS and is using remote Mac build machines to build my iOS and Android applications and PCs, VMs, to build my UWP apps. And now I'm building my entire application in mere moments every single time I push code. But of course, building it is great, but I want to test it. So when I tap on test, I can run all of my user interface automated tests right here. It'll automatically do one for me and take screenshots, but I've added some UI tests built in C#. So I'll go ahead and tap here. I could have used other frameworks like Espresso and Appium. So I'm going to look at the successful sign-on. And we can see I've tested this on 166 different iOS devices, including all the way back to iOS 9 and iOS 11 devices. And as I tap through, I can make sure my applications are working. And at any time, I can tap on one, get memory, CPU usage, and get valuable insight into my application. Then I want to distribute it when it's all good. So when I tap on distribute, I see all of my internal, but also public-facing beta and alpha tests, which is great, and automatically they'll be released. And when I'm ready to go to the store, guess what? You can automatically connect Mobile Center to Intune's Google Play, Windows, or Intune as well for distribution. Now, I talked about other services that Mobile Center has to offer, such as great crash reporting. You see, I've been doing pretty good in this app, except for that day that someone pushed some terrible code. But I can look into the actual stack traces and see what devices were affected. But better yet, I want to see how my users are using my application, and that's where the analytics comes in. And analytics with a cross-platform SDK and just a few lines of code automatically give me all my active users, daily sessions, top devices, everything I want. And I love a good dashboard, but I want the data, which is why we've enabled brand new the ability to export all this data into application insights with a single click. And I've done that already. So here is all of the data from Mobile Center into application insights. I can see all of my unique users over time, but better yet, I can, of course, open it inside of App Insights and run custom queries. So if I want to come in here and see my active users and custom events over time, this will now reach into that data and generate a pie chart for me to see where my users are using this application. And of course, you can export this and create all of those powerful Power BI dashboards that all of your bosses will love. I love them too. Look at that. Who doesn't love charts and graphs and all that goodness? But this is amazing. As a developer, I'm using Visual Studio to craft beautiful applications, setting up a full production pipeline with Mobile Center, and giving anyone in the company, and as me, a mobile developer, all of the data that I need, all from Visual Studio. Hope that you love it and enjoy Ignite. And let's welcome back Nat. Thank you.
Awesome job. All right. Thank you, James. That was great. Now, creating great apps that run on any device is actually just the first step, because we know all of our apps are powered by the cloud. And with Microsoft Azure, we provide you a scalable hybrid cloud that you can use to run small apps all the way up to enormous apps. But in addition to its scalability, Azure also gives you choice and flexibility in how you run your apps. So, for example, if you have some existing applications or workloads that you want to move to the cloud and start managing in virtual machines, you can just spin some VMs up in the cloud and put them there. If you want to take it a step further and offload more of your work to the cloud, you can use Azure App Service, which provides a pre-configured and optimized runtime for automatically scaling and managing the resources of your .NET and Node.js apps. Beyond that, if you're using a microservices-based architecture and you want to use containers, you can use Azure Container Service and Service Fabric to run and orchestrate your microservices. And then finally, if you want to go all the way to a serverless model where there's no setup at all and you want to use event-driven functions, and you just want to focus on the functions that you're writing, you can use Azure Functions for that. So with these choices, you have the option of outsourcing as much or as little of your operations to the cloud as you want at your own pace. The more managed services you choose, the more productivity you can gain, but it really depends on what's right for your application and your problem. Now, I've already mentioned some of the benefits of Service Fabric, and so today I'm very pleased to announce the general availability of Azure Service Fabric for Linux. As I mentioned before, Azure Service Fabric is Microsoft's microservices and orchestration platform, and some of you may already be using Azure Service Fabric with Windows containers. Well, with Linux, you get all the same functionality. You get resource governance, you get DNS, and you get deep integration with Azure Log Analytics. This is great. This means that from Azure, you can now manage Windows Server and Linux containers, orchestrate them all from one place. Let's take a step back and look at an example. This is Age of Ascent. It's a massively multiplayer online space odyssey game with thousands and thousands of players playing at once. And the team behind it deploys hundreds of microservices that run the game, all written using .NET Core, running on Service Fabric, which gives them automatic scaling up and down, and it gives them a self-healing capability. They love it, and they're really passionate about performance. It's critical for a game like this. And so in addition to getting great performance benefits from Azure and from .NET, they've also contributed back their own performance improvements into .NET Core because it is open source. And our other customers benefit from this. So for example, Raygun tells us that when they switched from Node.js to .NET Core, they went from 1,000 to 20,000 requests per second. The performance is really incredible. So it's not just about having a great cloud substrate for your applications. It's also about having a high-performance framework that you write your applications in on top of it, and that's what you get with .NET Core. It's high performance, it's open source, but it's also cloud-enabled out of the box. What does that mean? Well, it means the applications that you build with .NET Core are automatically ready to be monitored and to be debugged using powerful debugging tools in Microsoft Azure. So to tell you more about this, let's bring out our Director of Program Management for .NET. His team builds .NET, .NET Core, ASP.NET, and the developer tooling for .NET. His middle name is .NET. His kids call him Dad.NET. Here he is, Scott Hunter. Scott?
Hey guys. Thank you, sir. So we just shipped .NET Core 2.0 a couple weeks ago, and I want to talk about one of the biggest things about .NET Core 2.0, and this is something we did called .NET Standard. Over the years, we built a lot of .NETs. .NET Framework, .NET Core, we have Xamarin, and one of the things I want to do is I want to make it easy for you to write code and share that code across every .NET. And so that's what .NET Standard is. It's basically a huge standard library that works across all of our .NETs. What is really cool about this with .NET Standard 2, which is what shipped with .NET Core 2, we basically added 20,000 APIs back to the standard, which means if you tried .NET Core and it didn't have enough APIs for you, now it's got a ton of APIs. 70% of all the NuGet packages in NuGet.org are .NET Standard 2 compliant. And this means you can basically share that code across your front end, your back end, wherever you want. And so really happy about that. This shows some of the stuff that we brought back in .NET Standard 2.0. We brought back all the data stuff, data sets, data tables, all the XML, all the serialization, networking, I/O, and threading. So all this stuff comes back. It's out there today in Visual Studio 2017, and that is .NET Standard. So let's jump to the demo PC here real quick. And I want to show you some cool stuff we've been doing with .NET in the cloud. .NET Core is also our cloud-enabled and cloud-ready version of .NET. And that Contoso Air app you saw earlier, that's actually a .NET Core app. So here it is here. And one of the things that we've kind of learned is as you start building these cloud applications, you need more tools to make it easier to debug these things. It's easy to debug an app when it's running locally on your machine, but when you put it up in the cloud and you're scaling it across many, many nodes, how do you debug that application? So I'm going to show you a couple of cool features that we've added to make that super simple. So here is my Flight API. It's one of the APIs used by the web app. And what I'm going to show is a new feature we added. It used to be that when you publish your app to Azure, you might have to enable things like App Insights, or you might have to add a NuGet package to enable logging and stuff like that. And so what we've done is we've made .NET Core aware of Azure and Azure aware of .NET Core. And I can show you how this works. So my app's running up in the cloud, and maybe I want some diagnostics. So I come down here in the portal to diagnostic logs, and with ASP.NET Core 2, all I got to do is click on, and I'll say error level, and I'll press save. Now I didn't republish my app. I just turned logging on live in the portal. I can click log stream, and in a second this is going to connect. And just for demo purposes, there's a bug in my app. Dang it. And so looking at this information, maybe that's not enough. I can at least see that I've got some errors here. But let me show you something else cool that we did. what I can do is I will go back to the front here. And before I jump into the next demo, what I'm going to do is show this. So it used to be, if you wanted to add App Insights to a .NET application, you'd have to go add some NuGet packages and stuff like that, which, after your app's published, you probably forgot about that step, or you didn't know that you had to do those things. We've now made it automatic. So if I come up here and I click here for App Insights, it will take me to a blade, and I can just click OK here. We will add App Insights to your project in the cloud and wire everything together for you in the cloud with no republishing of your application, and you just get all that for free. So I'm going to jump back. I've already done that on my Flight API. And so what I'm going to do next is I'm going to click here to load up the App Insights blade. And you'll see that I get to see some information right away. I get to see my requests, which these are the slowest requests in my site. So it's showing me I've got some requests that are 280 milliseconds, 3.4 milliseconds. Those are really fast. But let's go even further. I'm going to drill down here, and I'm going to open up full App Insights for this application. Another neat feature we've done is we know that when you build cloud apps, you're going to have backends and front ends and microservices, and really you need some kind of view where you can look at your entire application and you can see if it's having problems. So I'm going to open up this app map right here. And this is going to show, this API app is not too complicated, but you're going to notice there is I've got a warning here that something's wrong here. So let me click on this. And what we've done is we've actually installed a profiler in the app running in the cloud. And what it does is it looks for common exceptions, and it looks for places where your application performance might not be good. In this case, notice I have 398 errors where I'm getting a null exception. Now, typically what you would do is you would tell your developer, hey, go add some more logging into this application so I can drill into that and republish. Not anymore. With App Insights, I can click on that error. I get a lot of information here showing where the request came from. It shows me a little bit of my call stack. But there's this new feature called Open Debug Snapshot. And so what we do is when we detect that an exception's happened 6 or more times, we actually take the process running in the cloud, we pause it for 2 milliseconds, and write the entire process out to the disk, what we call a debug snapshot. And so now you're going to see here I've got my full call stack. I can drill down at the bottom here and open this up and see all the variables live in the app. Because it's really, this is actually, let me look inside of the actual app running here. Now, that's great, but I'm a developer and I really want to do this in Visual Studio. So notice I've got this download snapshot button right up here in the right corner. I can click that and we'll download that snapshot to the local machine. And I've already done that. And what I can do is I can open up, here's my download folder in my box. Here's that exception. Let's click this. It's going to open this file in Visual Studio. And I'm going to click Debug with Managed Code Only. And now look at this. I am now exactly where that exception occurred in the live application. I can see the full details of the exception in Visual Studio. And I can actually browse around, look at the variables. Basically, this is cool because we didn't stop the app running in the cloud. That app continued to run and did its thing, but now I get all the debug information. We have another cool feature here as well, which is I can go over here and click on my App Insights tab. So I've looked at this. We've got a problem here. So I'm going to click this. I need to click an exception, so let's do this. And we will run this here. 1 second. Here we go. And so the next thing I want to do is I basically I've got my Visual Studio connected to App Insights as well, and to VSTS, and I can find the exceptions here. I can click on the exception, and then I can do Create Work Item. So right here, because I'm wired up to VSTS, Visual Studio Team Systems, I can come right here. This is a problem, and I'll actually file a bug right here against a developer. And if I wanted to, I could actually, there's all the information. They get the full stack. Done. I saved that to the cloud. So without changing my app, republishing my app, I was able to look at the live streaming logs. I was able to actually look at the exceptions my site had, actually download those exceptions, view them in Visual Studio, and file an issue against my developer, all in VS. So super, super cool features. I have one more thing I want to show. Let's switch to the Mac. This is Visual Studio for Mac. It has full support for .NET Core 2, ASP.NET Core 2 built in. And what's cool is I have that exact same site in Visual Studio for Mac. And so whether you're a developer on a Windows machine, a developer on a Mac, or you're using Linux from CLI, between Visual Studio for Mac, and VS Code, we have a solution for everybody. So that's all I got today. I hope you enjoyed this, and I'm going to bring Nat back up.
Nice job. Thank you, Scott. That was great. So as we discussed already, users today are generating data at a greater scale than ever before. And so as developers, we need to store that data and manage it, and we need incredibly great infrastructure that allows us to do this. And the average team just can't afford to build and maintain that. Now, collecting and storing your data is just the first step. Once you do that, you need powerful information services to help you analyze it and make intelligent decisions. Microsoft's data and AI platform makes it easy to add this kind of data intelligence to your app. With Cosmos DB, you get a globally distributed database with sub-10 millisecond response times. Cosmos DB also has multi-model querying. Now, if you don't know, what multi-model querying means is that you can have a single data set which you can query using different query languages. So for example, you can make relational SQL queries against the database. Then against the same database, you can make a NoSQL query, or even for graph operations, graph queries. And you get the same locality and performance for all of those different types of queries. With Azure Functions, you can add logic to your app without provisioning any servers or setting up any application frameworks. And it automatically scales out with your workload. You just focus on the function that you want to write. It's like almost the most pure form of development. One of our customers, Fuji, told us that when they switched to Azure Functions and serverless computing, they were able to reduce their development costs by 75%. And then finally, cognitive services and bot framework make it easy to add advanced human-like intelligence to your app in just minutes. So to show you all of this, please welcome Program Manager for Azure Functions, Donna Malieri. Donna?
Awesome. Thanks, Nat. I'm so excited to be here. Let's go back to the Contoso Air sample that James showed us. This is Microsoft's favorite fake airline. Now, think about what it would mean to build this application for real. Not only do you need a great website and a great mobile app, but it needs to be fast. It needs to be reliable. It needs to be scalable. And it needs to serve users all over the world. It used to be that building an application like this was really challenging. You needed expertise in databases, in distributed systems, and even then, it was really tough. I'm going to show you how you can use my two favorite services, Cosmos DB and Azure Functions, to build this. You don't need any specialized skills. An ordinary developer can do this because, as Nat said, let's not type faster. Let's skip steps. So first, I'm going to book a flight. Now, this step is really important because James and I compete to see who has the most fake miles. So think about what's happening in the database as I'm doing this. It's checking inventory, and when I go through and book the flight, the number of available seats will be reduced by 1. So if I happen to get the last seat on the plane, and James tries to go and book the flight, then he shouldn't see it show up at all. So in the database, what this means is that when we query available flights, all of the pending write operations have to have completed first. This is known as strong consistency. And this is how databases have traditionally worked. Now, strong consistency is not the only consistency model. There's actually a fundamental trade-off between the consistency of the data that you get and the latency of your queries and the scalability of your database. If you need your data to be perfectly consistent, you will sacrifice some latency. So that's why there's another commonly used consistency model, eventual consistency. If your application can work with data that is sometimes stale, you will have faster queries. You will be more scalable. It will be more reliable. So a social networking site will often use eventual consistency, while an e-commerce site will use strong consistency for transactions. But this is what we noticed at Cosmos DB. Most applications do not fall into one of these two extremes. We want intermediate consistency models. So that's why Cosmos offers 5 well-defined consistency models, because applications need to be able to choose the model that fits their needs. In fact, 97% of our customers use one of these intermediate models. So for instance, let's say you're building the shopping cart of an e-commerce site. You can use session consistency for that. What that means is that an individual client will see their own reads and writes. There will be a consistent view, but you don't need to actually change inventory for other customers until the transaction has actually been committed. Now, with Cosmos DB, you don't even have to choose your consistency model up front. You can change the default in the portal, and you can even choose a different consistency model for a specific query. So here, if I go to the website code in Visual Studio, you see that I've used strong consistency for all of my queries. I could override this on a query-by-query basis, meaning that you have power and flexibility. Now, Cosmos DB is not just fast, it's not just scalable, it's not just reliable, but it's also super easy to use. You can use either SQL or graph queries to get to your data. And this is not something you have to configure. It's not a decision that you have to make up front. So let's go ahead and do a simple SQL query. I'm going to go to the flights collection, and I'm going to say new SQL query. And let's get that flight that I just created. So you don't have to learn a new query language to use this new modern database. So we run the query, and we get our flight record. Now, in the real world, data is not always relational. For example, think about flights. You know, code sharing is so awesome that the airline industry has gotten in on it. They don't share actual code, but they share flights. So you go to Contoso Air, and you can book a flight. You can book that exact same flight on a partner. And the flight will have 2 different flight numbers, but they're actually the same logical flight. That's an alias between 2 entities. Expressing that in SQL is really challenging. So you want a graph query language, such as Gremlin, which is what Cosmos DB supports. So let's go ahead into this code share collection and query something so we can see the power of graph queries. So here, what I'm going to do is I'm going to query all vertices in this graph that are a flight that's going to Seattle. And since this is sample data, we don't have that many flights, but we can also zoom in and see all these flights and the relationships between them. We could even zoom in on an individual node and see the information about it. But think about how hard it would be to write this query in SQL. You would need a lot of join statements. Now, let's look at a query that's actually impossible to write in SQL. Let's look at all flights and all the relationships to every other flight in the system. And look at how fast it returned the results. Basically, this is similar to the kind of query that you would write in a programming language where you're traversing a graph. And you get to express this in a very natural way using this graph query language. And of course, you can do these queries in your code or right here in the portal while you're trying things out. So Cosmos DB is fast, it's reliable, it's scalable, it's multi-model in terms of your database querying, and it's just gotten even better. Today, we're announcing integration with Azure Functions. If you think about it, you don't just need to read and write data. You often need to take action when the data changes. Let's say the gate for my flight has changed. The Contoso Air mobile app should send me a push notification so that I don't miss the flight. So we want code that runs triggered on a gate change. Azure Functions is the best place to write this code. Azure Functions is serverless, which means that it scales automatically. You don't pre-provision compute. The system does it for you automatically, and you only pay per execution. You don't have to reserve compute and pay for it ahead of time. So here I am in Visual Studio with our best-in-class tooling. I have a C# library that uses the new Cosmos DB trigger. What this does is whenever there is a change in the flights collection, it is going to send the set of changes to this function. It's going to trigger this function. If there are a lot of changes and they're happening very rapidly, the system will automatically scale me out to more instances, and I'm charged per execution. And then as the number of events scales down, I'm scaled down automatically. So that's something you don't have to think about. You get to focus on your application, not the infrastructure. So because this is Visual Studio, you get all the features you're expecting. You get IntelliSense, you get unit testing, and of course, you get debugging. So let's press F5. Now, this is the thing that makes Azure Functions the best serverless compute experience on the market today. When I press F5, I'm running the Azure Functions core tools. This is not an emulator or a simulator. This is the same runtime that runs in Azure. You have a high-fidelity inner loop experience running on your local machine. So you don't have to push your code to the cloud just to see if it works or not. It gets even better than that. You can trigger off of data that's in Azure. You don't have to mock the data. So you get a hybrid debug experience. So let's see this in action. So here I have a breakpoint if the gate changes. I'm going to go into the portal. I'm going to go to Cosmos DB. And this time I'm going to do a graph query on my flight. I'm going to do the same query I did before, but this time as a graph query. And I'm going to go ahead and change the gate. I'm going to be nice to myself, so I'm going to just make it one gate over on my fake flight. And if we go to Visual Studio, you'll see just like that, the breakpoint hit. If I go in my locals window, I can see the message that's going to go in the push notification. Let's change this message. Let's make it a little bit more friendly. Have a nice flight. Exclamation point, continue. This is going to send a push notification with Mobile Center. We can see the message of the notification that it's going to send right here in the output window. So that's how you can use Azure Functions and Cosmos DB to have a very productive experience where you get to focus on your business problem rather than the application. And this week, we're announcing that we've made these tools cross-platform. So if you use a Mac or Linux, you get the same great debug experience. And we'll have sessions later this week where we drill into that. I can't wait to see what you build with Azure Functions and Cosmos DB. Now I'd like to invite Paul Stubbs on stage. He's going to add intelligence to this application using cognitive services.
Hi, thanks. Thanks, Donna. I'm excited to show you how to add intelligence to your apps using Microsoft Cognitive Services and the Bot Framework. Cognitive Services enables you to infuse AI into your apps with only a few lines of code on any language, on any platform, including iOS, Android, and Windows. Cognitive Services is a set of 30 APIs that enable your apps to hear, see, speak, and understand the world around you. They're continually improving, and they're available to get started for free on azure.com/cognitive. And Contoso Air thought it would be interesting and fun to have a new way to rate your application using just your emotion. So here I'm able to simply come up here and provide feedback using simply my face and my voice. So let me show you how that works. So here we can take a photo of me smiling. It sends that photo to the cloud, and we then detect the emotions, which will then calculate the rating score. We can also add a voice response. This is an awesome application. So here, we're able to see and understand what's being said and the emotions of the information being sent, and then we can submit our feedback to the cloud. Let's take a look at how that happens. So here in my Azure portal, we've created a flow application, and the flow application is able to take that rating that we've sent to the cloud and then look at it and decide if it's a low score to automatically route that to a Microsoft Teams site so that my customer service members can take care of that customer. And on the code side in Visual Studio, it becomes very easy to add code for the cognitive services. And we can see here in Visual Studio, this is a simple Xamarin application for iOS. I handle the on-sync function from the camera. Then once we have that, I'm able to pass that stream to our happy function. And then the happy function will take that photo and calculate the rating and then calculate the stars. So the way the happy function works is that we simply create an instance of our emotion client, which is a REST service, with the key that we use to register. And then we are able to call that service. We get back our results, which is a simple JSON result set that has our happiness value. And from the happiness value, then we can calculate the score. Well, if we come to the emotion website on Azure.com, we can register and sign up for our key, but we can also see examples of how to use that API and actually try out that API as a developer. And you can see here the results we get back. Not only happiness, we get back a number of other emotions as well, such as anger, contempt, and disgust. But now, recently my flight was delayed and canceled because of weather, so I have to rebook my flight. Now, I can do the normal ways. I can call, I can go to the website, I can contact them through email, but I can also now use a bot thanks to Contoso's application. So if we come back to our application now and go to the customer service function, here I'm able to communicate with Contoso either through Skype or Facebook Messenger using the bot framework. So here I'll use Facebook Messenger. So now with the cognitive services, I can also communicate in any of 60 languages thanks to the translation API. So for example, if I wanted to have the conversation in Spanish, I could simply say hola, and the cognitive services will recognize the language that I'm communicating with and will automatically change the language of my conversation to be Spanish. So let me go back so that we can do this in English. So here I can simply switch to English. Again, Cognitive Service Translation API recognizes the language and initiates the conversation in the language that I choose. So now I'm back in English. I'm presented with a number of rich carousel controls so I can choose the flight that I need to rebook. So we'll say option 3. Here we're presented with the information, so I can say, well, is this the right flight? This one leaves at 6:40, arrives at 8:50. So let me confirm. We'll say yes. I'm presented with my boarding pass. So now I have a boarding pass, which saves me time from having to go to the gate and print one out. Do I want to see a terminal map? Well, I'm not very familiar with this airport, so I'll say yes. So I have my boarding pass, and also the conversation recognizes that I had trouble with my flight because it was canceled and offers me a drink coupon. Well, I don't know. Let's see if it knows more about the drink coupon. So here we're able to pass general information questions to our bot, and the bot is able to answer because it's using another cognitive service called Q&A Maker. So Q&A Maker enables me to provide a knowledge base of information for my bots and other applications. So let's take a look at how that works. So at Q&A Maker website, we can simply create new knowledge bases from FAQs, from documents, from manuals that we may have lying around. So you can see here, I have a simple knowledge base, which is a set of questions and answers, and we're able to ask information. I can even test my bot here from here as well, so that we can say, I want... The bot is automatically backed by language understanding, so I don't have to exactly have the exact question. The language understanding service will interpret what I'm asking and find the right information for me automatically. So let's take a look at how that bot is actually created. So coming back out to Azure, what we can see here is that we've created the bot using the Azure Bot Service. So the Azure Bot Service is hosting our bot, and it provides the channels available to us for our bot to run in. So while the bot is loading, what we can see is that we'll have the channels available to us. We'll be able to see the information about our testing environment. Let's give this one more chance here. Let's jump out to the Azure code while that's loading. So here's the same code that runs in Azure. We're able to load the code inside of Azure if we want to, inside the Azure Bot Service. And we're also able to debug that same code and develop that same code inside of Visual Studio in Visual Studio like we know. So here, for example, is the code that calls Q&A Maker. It's very simple to call. All I need to do is have the key and my subscription key for the knowledge base. And then we just simply pass in the question, and it returns our answer. But the answer is also passed through translation service, which enables me to translate all of the questions inside of Q&A Maker back with the bot as well. So I'm able to not only call Q&A Maker service, I'm able to call the translation bot as well as we go through. So last thing I want to show you here is around the creating custom speech. So a lot of times we have speech, we're in noisy environments. And so within a noisy environment, we need to train our speech model to understand technical terms such as airport codes, and it could be a lot of airport noise. So in this case, we have the ability to send information to our speech model and get back our events, and compare that to a base speech model that's been untrained. So let's go ahead and run this.
Show me all flights from Pittsburgh to Boston, both direct and connecting, that depart Pittsburgh after 7 p.m.
So you can see there was the airport noise in the background. The base speech model and the custom speech model both correctly interpreted the intent, which is flight information, but the confidence level on the custom speech model was much higher. The custom speech model was also able to pull out extra entities and understand more information about what was being said. In this case, it understood that there was a time entity involved in the question. And so once we have that information, we're able to then handle that better, and we can look at that information on the back end here in our Power BI dashboard. And the Power BI dashboard rolls up all the kiosks at our airport and can show us the conversations that are being said from all the different airports. So for example, we can see a word cloud of the different types of conversations. We can see the number of conversations being had at the airport. We're able to see information about the number of intents, what kind of questions are people asking to our bots and to our kiosk. We can also see the sentiment over time, so we can understand how people's emotions are. And we can also see the actual airport and the intents mapped to the actual individual kiosk. So here on kiosk number 2, for example, which is red, we can see that there's some dissatisfaction. So if we drill into that kiosk, what we can see is that the onboard intent has a lower satisfaction at that kiosk. So maybe the people are having trouble finding onboarding information. Maybe there's some difficulty with Wi-Fi. We're able to understand the intent and the sentiment of the people at various locations and able to understand how they're doing. So what I've shown you is how to add intelligence to your applications, whether it's a mobile app or whether it's in the web, using Microsoft Cognitive Services and the bot framework. So thank you, and have a great conference.
Nice job, Paul. Thanks. All right, thank you, Donna and Paul. So far, we've seen some powerful tools and building blocks and services that can help us all build innovative apps. But developer productivity is not just about what we build, it's also about how we build it. And increasingly, teams are finding huge benefits from adopting agile, iterative techniques and methodologies for software development that allow them to rapidly improve their apps. If you're able to build and test and have all your tests pass and release your software every day, this enforces a kind of discipline on your team that actually increases your overall velocity. And so this is becoming a core part of developer culture. And this is true at Microsoft, too. You can release your products every single day, and actually that's already true of some of the largest products at Microsoft. And we use Visual Studio Team Services to do it. Visual Studio Team Services is an integrated DevOps platform for any kind of app. It provides source control, it provides continuous integration, deployment, testing. It also provides a great collaborative, agile planning tool that your teams can use to collaborate. And to hear more about this, let's bring out Visual Studio Team Services Program Manager, Abel Wang. Abel, come on out. Abel.
Thanks, Nat. Man, we have just seen some unbelievably cool tech. A modern, intelligent app that can run on any device, that harnesses the power of Azure with containers, with functions, using Cosmos DB and cognitive services. Get out of here, man. That is some cool stuff. However, all of this coolness, it does come at a price. Without the ability to automatically build and deploy my app through a pipeline all the way up into Azure, it limits me. It limits me from continuously delivering value to my end users. And in this modern DevOps world that we all live in, we absolutely need to always innovate and add new features and new values for our end users. But don't worry, I got this. We're going to fix this problem. What's that Donovan always says? We need to rub some DevOps on it? Not today. Today, we're going to drop a bucket load of DevOps over all of this, and we will make everything better. Visual Studio Team Services is the ultimate DevOps solution into Azure. It's everything I need to take an idea and turn it into a working piece of software. So let's go check it out. So up on the screen, what you're looking at right now is the dashboard into Visual Studio Team Services. This dashboard is fully customizable, where you can make it display whatever you want. And the way you do that is by adding and removing widgets. Out of the box, VSTS comes with a slew of widgets. You can even jump to the marketplace. And in the marketplace, you can download other people's widgets and just start using them. And if what you want to do doesn't exist out of the box and doesn't exist in the marketplace, just build your own widget. So if you can dream it up, you can create a dashboard that matches it. Now, next, I need to do some work. But you know, I can't just dive into my code all willy-nilly. I need to be able to plan my work and track my work. And in Visual Studio Team Services, we have the ability to track any unit of work for a software project. Now, the way we do this is through the backlog and through the Kanban boards. Now, in the backlog, I can add new units of work. I can prioritize my work. And when it's time for me to track my work, I can jump into the board and I can visually track the progress of my work. Now see this beautiful Kanban board? This is also fully customizable. I can customize the columns. I can customize the swim lanes. I can even go in and customize the data that shows up on each individual card. Now, notice the bug that Scott created earlier. It's automatically shown up in my Kanban board. Pretty cool, huh? All right, so what we're going to do is actually do some work on this. So let's go ahead and assign this to me. And this is really important, so let's go ahead and turn this into a priority 1 bug. And see how the color changed? That's because we can even set up style rules that gets triggered off of any field in the work item. So now, as I do work, I'm just going to walk my work item across the board. Now, as a developer, once I start work, what's the first thing that I need to do? I need to be able to create a branch. And you're able to create a branch directly from the work item. So let's go ahead and create that branch. And bam, just like that, I've created a branch for myself to work in. So let's jump into the command line, and let's go ahead and pull this code down. And once we pull this down, let's go ahead and check out that code. And now, let's make some changes. So the first thing I'm going to do is add some demo code here. And let me add some code over here as well. Yeah. Is that fast enough for you, Nat? Typing fast enough now? All right. What are we going to do next? We're going to jump in, and we're going to add everything to our repository. Let's go ahead and add. We'll do a commit. And let's go ahead and push our code back up to VSTS. Now, once we get the code back up to VSTS, VSTS is smart enough to actually know, hey, you just checked in this branch. Do you want to create a pull request? Which, of course, I do. So let's go ahead and start the pull request workflow. Now, you can see it's already created a title. It's created a description for me. It's even automatically assigned the work item that was associated to this particular branch. Now, I can start assigning people to this pull request, or I can actually have VSTS automatically assign people based on the folder that my work is coming from. So in this case, let's just say anybody on my team can do this. And once I create my pull request, I can jump into the files. I can see every single file that has been changed and what has changed. And now I can start leaving my comments. So let's go ahead and leave a comment. How about that? And you know what? Let's go ahead and leave a reply. But let's leave a reply in the form of a GIF. And there you go. I wish all my pull requests were like this, right? So what happens if my pull request was not brilliant? Well, all I would need to do is just keep on working in this particular branch, upload it, and continue on with my pull request. And at some point in time, we're either going to approve this or we're going to reject it. And then, eventually, we can go ahead and complete this. Now, upon a successful completion, it's going to take my code and merge it into master, right? But before it does that, it can take the work item that is already linked to this pull request and close it out for me. VSTS can also go in there and automatically delete this feature branch for me so I don't clutter up my central repository. And finally, it can take all that chatter that's going on in this particular branch, right? All my check-ins. And it can squash that down into one clean check-in into the master branch. And once code hits my master branch, that's when it kicks off all my builds. And I have builds for mobile using Mobile Center. I have a build for the Node portion. I have a build for the .NET Core portion. So you see, VSTS, it's not just for .NET and the Microsoft stack. It's for any language, targeting any platform. Now, this build system is basically just a task runner. It does one task after another, after another, after another. So here, where we're storing our packages, we're going to go ahead and build our .NET Core app. We're going to package everything up, ready to be deployed. And then we're going to actually go and build our Docker container. And this is a Linux Docker container. And when we're done, we'll take that Docker container image and we'll send it to Azure Container Registry. Right? So how do you customize this build? You do that by adding and removing tasks. And out of the box, there are hundreds upon hundreds of tasks that are pre-built that you can just use. And these tasks span all sorts of languages and all sorts of platforms. Now, million-dollar question. What happens if you want to do something that doesn't exist out of the box? Well, the first thing I would do is jump into the marketplace. In the marketplace, our partners have created over 500 build and release tasks. If you find what you need, just download it and start using it. And if what you want to do doesn't exist in the marketplace or doesn't exist out of the box, you know what you do? Just build your own custom task. Custom tasks, they are nothing more than PowerShell or Node.js. So what that means is anything you can do from the command line, you can easily build a custom task and have VSTS do it. And what that translates into is you can get VSTS to do whatever you want. All right. So once my build is successful, it's going to go ahead and kick off my release pipelines. And I have a release pipeline for my mobile, once again through Mobile Center. And I have a release pipeline for my Node portion. And I also have a release pipeline for the .NET Core portion. Now, if we jump into the pipeline for the Node, this is actually pretty interesting because the very first thing that we do is we actually deploy the entire infrastructure out in Azure for Contoso Air by using an ARM template. And once we do that, the next thing we do is we deploy the Node portion by using one app service task. And if we go ahead and go to the container service, the task that we do here is the very first thing that we do is we go to Azure Container Registry and we grab the image that we want to deploy. And the next thing that we do is we take that image and we deploy it to a Kubernetes cluster. And once again, it is just two simple tasks. And when that's done, we propagate it from dev all the way out into prod. So there you go. End-to-end DevOps using VSTS. Visual Studio Team Services is the DevOps solution into Azure. There is nothing out there, people, nothing out there that is faster or easier or better at taking code from the fingertips of my developers into the hands of my end users using the infrastructure in Azure. Thank you, guys.
Thank you, Abel. That was some very nice typing. Clearly a Dvorak guy. All right, you've seen a lot from us today, and I think what's most impressive is how well all these services integrate with each other. You really can turn to Microsoft for a complete developer platform for any app that you might want to build. But we also know that each project and each developer has unique needs and demands. And so in recognizing that, we've designed everything from the ground up. The Microsoft Cloud, Azure, the entire data platform, and our dev services are all designed to be modular and composable and open. You can pick and mix and match what works best for you. All of this is about making you as productive as possible and ultimately as successful as possible. So we hope you have a great show, and we can't wait to see what you build. Thanks.